So what was the goal of EPC RECAST, which was one of the many projects working on improving EPCs? So it was an R&D project in innovation action. The idea was to focus on residential buildings and to develop a process and associated digital toolbox, to facilitate and improve the working practices of EPC assessors. So what was very specific to the project was to focus on the daily practices of an assessor, following the steps he or she has to do to issue an EPC for a given dwelling. So the idea was that with this set of tools, we would have less discrepancy between several assessments done by different assessors of the same dwelling. So to reduce the gap between the work done by different professionals in the EU. And our second core focus was the building owners. To improve the renovation recommendations we could include in the EPC and in associated renovation roadmaps that could be issued at the same time as the EPC and sent and provided to the owner. So I will not deal with all the topics in the project, of course. Just to say that we were 11 partners. Some of them, I guess you know them. So we were with Tecnalia, Fraunhofer, energy companies in France, EDF&G, Polimi in Italy, Research Center List in Luxembourg. And we had so NB with Yana attending today, Riva with Andrei, R2M, and Bineo with a French company that developed a tool to do on-site visits of buildings. So the project objectives was to use novel methods like data collection and quality checks to improve the first step of the approach, which is the data collection on site. So second step, you have the energy performance assessment with the energy simulation back at the office, and then the certification where you issue the EPC and provide it to the owner. The idea was that the approach should last around 1 day as a maximum, or less than half of 1 day, with half a day of on-site work and then the other half day back at the office. So with the cloud system toolbox, I already said all of these things, and we had feedback from public authorities from different countries with advisory board and the industry with the mirror group. So just to recall again the 3 steps. First one, data collection and inspection process, and then energy performance assessment and certification and renovation roadmap. So if I try to present the core process, what we did first on site was to use a tool developed on an iPad, on a tablet, that you use to scan the building. So I have several pictures of that here. So you detect the different walls inside the dwelling. Then it does cross checks the infinite plans that it has detected, and it generates a BIM model of the building that you can see here. And you can generate then blueprints of each floor. So it can be used to get the right geometry of a dwelling, so from the inside. You cannot scan a whole building with that, so it's not for multifamily buildings or non-residential buildings. It's just for single-family houses or flats inside multifamily buildings. But still, it helps to streamline and increase the fluidity of the process and spend less time. You can also make pictures, annotate the blueprints, so take a lot of information, answer questionnaires inside the app, which you can then you can annotate the blueprints you have in the app, so that you centralize all the data collection and observations about the building inside just the same software and the same digital project. We did other things, but I will not present them, like on-site measurements of thermal characteristics of the walls. Just the key central point is that once you have collected this information, it's stored into what is a simple digital logbook, which is based on a French technology developed by CSTB, the Croquis technology, which is a platform where you can manage files, and add different web services integrated. But at the heart of this, you have an XML data model. So it's like an HTML file, which Antoine will present, which specifies all the information you have, identified about all the building components, so the walls, the windows, the heating, HVAC systems, etc. In theory, this file could be connected to many things, to images, to bills, to database, etc. So we have not integrated all the connections in EPC RECAST, but that's something we are able to do at CSTB and that we could do in other contexts. So the central model is really, data model is really at the heart of the project. And then, so the idea is, as you can see with the row, so you store the information in this file. Then it's used to do, on some cases, a model calibration. It was done by our colleagues at Tecnalia in Spain with Energy Plus to evaluate some input parameters. And then we developed a process that allows you to do dynamic energy simulation with a simulation engine that was developed at CSTB for the new buildings. Sorry if you, I just hear some background conversation. Okay. So here is the process in more details. On the left side, you have the scans and measurements I talked about. So it's stored then in the end in this XML file, which is stored then on this web-based toolbox, which is a simple digital logbook. And then we developed a simulation interface, which looks like that. It's close to an EPC software. It was just developed for the purpose of the project. We are not software providers at CSTB. It was just to do the test. And then you have conversion algorithms which convert this data set, which corresponds to what you're requesting today to an EPC assessor, into a more detailed data set that allows you to run a more detailed dynamic energy simulation. So the point is that if normally you do dynamic energy simulation, which with an engine like Transys, Energy Plus, Comet, and other tools, it's rather for energy consultancy companies because it takes more time. You need to have better training to do that. And an EPC assessor is not trained enough to do dynamic simulation. So he has to collect the same amount of data as today, but then we do the conversion to transform this data set into a more complex one and to run the dynamic energy simulation. And that's also connected closely to this data model, which is the entry point. And then we store the results from the dynamic energy simulation inside the data model. So that's what we did there, and it allows in the end to fill in an EPC template that was developed by Jana, who is today with us, which was closely related to the revision of the EPBD. So we monitored the evolution of the EPBD to define KPIs and information we should have as a minimum in this template. So this is how we did the process. So just to close on EPC RECAST. So in the end, you do the energy simulation, you store again the results into the data model, and from that you are able to have your next generation EPC. And we also implemented a renovation roadmap tool, which is a simple one that makes simplified renovation scenarios, which is also based on the data model of the building. So you read the data model, you have the current state of the building, then you define your renovation scenarios, you do the simulations, and you get the roadmap in the end. So what we demonstrated in the project is that we proved that it was feasible to have an integrative digital workflow to improve the daily practices of EPC assessors with a common data model and a set of digital services. We proved it was possible to make interoperable different reporting and regulatory tools like renovation roadmaps, passports, EPCs, and other tools like national database, even though we did not implement that, thanks to a common data model of the building. So just to move to the final thing is that to have an implementation in national markets, we do need IT development strategies from software providers who would provide such tool and digital workflows with professional software and interfaces to professionals. And we need data standardization of these data ecosystems and data models at the national scale and European scale to facilitate the development of tools that could better cooperate between themselves. So that was about EPC RECAST, but then I let Antoine present, share his screen and present elements about the French national database.
Do you see my screen correctly?
Yes.
Yes. Okay. So yeah, I will present you the French National Building Database, which is an initiative by CSTV to gather all information we have on buildings on a single IT object. So the first, the state of the building data in France before the EPB is what we had a lot of building data, but they were scattered among use case specific database. We had the physical administration with a lot of information on buildings. We had 2D building geometry. We had a lot of information on building permits, real energy consumption of buildings, but all this information were produced and by different organisms, and they were not interoperable, which was the main difficult to be able to do analysis of buildings on multiple indicators. If you have the specific use case, you can manage, but when you want to have a broader perspective on your building, you are blocked. And what we did is to gather all these databases in one single object, which is the National Building Database, where we do all this matching of data from all the sources. And we have also an approach of modelization and KPI calculation for building that needs information to be able to provide intelligence on what is the performance of the buildings in France. And so for that, we use a lot the French EPC database. But the French EPC database is incomplete at the moment. It covers around 25% of building, which is already huge, but it's not enough. So we have developed also methodologies to try to forecast and predict EPCs on building that needs a proper EPC. And so with this, we are able to pilot public policies and to analyze the French building stock. So in this example, we are able to identify that 20% of the building houses correspond to 50% of the CO2 emission reduction if we renovate them heavily. And the thing with the BDND, which is very interesting, is that you can compile those statistics and those elements, but you can also then localize specifically the buildings that are concerned. Like, for example, if I want to identify the 20% of building you want to renovate to make this 50% of GS economy, you can identify them on the stuff. So that's one use of the French EPC data model that we do. And I will present you what we have done with the French EPC data model. So this is from the new reform we had in 2021, which is an ambitious reform for the EPC in France, where we have set up a lot of key aspects that are providing very good result at the moment is that we have an enforceable description and measurement of all the components of the buildings, which means that if they are wrong, they can be contested for real estate transaction. That means if, for example, a building is established to be insulated for walls, but it's not, then it can be contested and say you are devaluating my building value. So this forces the assessor to fill valid information. The source of the information is explicit for each component, so you know if the information is coming from a document, a measurement, or an observation. And for the document, you know which type of document was provided to provide the information. And also the data model we provide is at the descriptive level for each component. And you have all the descriptive information to rerun the calculation of EPC, and it's stored in the national EPC database. And so it's very easy to get and easy to integrate in renovation process. So here, if I have done an EPC in 2021, then if I renovate my building in 2024, I can get the EPC and easily integrate this EPC to my renovation process, see what's the best renovation to do for my building. And also an aspect that is very important is that the EPC is properly identified with an address, a building number, and housing using a unique tax administration number to be sure to locate properly the EPC. And another aspect is that with this reform, we have the number of EPC sent is skyrocketing, because you can see the number of EPC before the reform was around 2,050, 257 EPCs, and now we are around 800,000 EPC for freelancers. So it's huge, and with these numbers, we could cover like 50% of residential building in less than 3 or 4 years. So also the EPC document, which is in XML, is sent to the French EPC database, but it's also validated and verified by an algorithm that check a lot of inputs that are provided, and a lot of EPCs are rejected because they are provided with errors. And so the EPC has to provide a valid EPC that fill all the consistency check. For example, if you have forgotten to fill the thermal bridges on a building, you will have this. You will have an error. You have a lot of consistency check that are running right now. So that all the EPC that are served in the database are checked with quality. And so just to finish, for the EPC recast data model, we based it on the French EPC logics, is to have descriptive model for all its components. So the idea is not to have the numerical values as the first input for each component, but the property you can observe and measure, so that to have a model that can be shared with a different modelization solution. So even if you have multiple simulation tools, Then if you go back to what you can observe and measure on a building, you can then go, for example, when Olivier presented, you can use a dynamic simulation model, or you can still be on a static simulation model if you want. But it's very important to be at the descriptive level and not to be on the implementation level of a solution dedicated to one simulation tool. And that's the approach we have in France, but also in the EPC RECAST. Also we have made some improvement and link to some European norm, especially for our HVAC systems, because we have database in Europe that have a lot of performance indicators for new systems. And the idea is when you have new systems in EPC RECAST, you can link them to this European one. So that's it for the presentation of French National Database, French EPC, and the link with EPC RECAST.
Okay, I will go to the brain. I will make a very brief introduction to the iEPB main objective. Okay, in each of our countries, there are many assessments that our buildings must to carry out and comply with. Some of these assessments are defined in the European directive, and others are defined by country or by client own wishes. For example, BREEAM, LEED, you know. But what is clear is that many of these assessments share data about the building with each other, and that every time one of these assessments has to be carried out, a technician must to collect the necessary data about the building in order to carry out the assessment. This means a lot of duplicated work and in some cases even mistakes. Why don't we make it easier? That is the main objective of the iEPB project. The iEPB project aims to create a common data model for all building assessments, and this common data model will be the iEPB schema. This is the main objective of our project. That allows common data to be shared between assessments. And when we talk about data sharing, we mean both input and output data, that is the results of the assessments. For example, the properties of a building, surfaces, constructions, materials, geometry, air conditioning systems, etc., could be reused from one assessment to another. So Miguel Ángel will explain in what we are creating in the iEPB schema.
Okay, so when we thought about how can we do to get a common format for the different assessments that we have related to the EPD, we thought, okay, we cannot create something new. We cannot reinvent the wheel. So we have a look at what's already existing. And for example, related with the energy assessment of the building, related with the EPCs, related with the energy audits, we have the green building schema. Okay, this green building schema is an already existing format for BEN models. And this schema is founded by organizations such as the Energy Department of the United States, the Renewable Energy Laboratory, Autodesk, and so on. This schema is present in softwares like the AutoCAD, Revit, and also in SketchUp, and many other softwares are already using and exporting to this format. And in relation with the life cycle global warming potential, that is another assessment that is going to be mandatory in the future years, there is also an existing format, the International Reference Life Cycle Data System, that's the ILCD format. So if we are going to store information regarding the building simulation, or if we are going to store information for the global warming potential, we should reuse the existing formats that we have here. But really, when we are dealing with EPCs and when we are dealing with SRIs or with the building renovation passport, we need more information that can be stored in the GBXML or in the ILCD format. So we propose, those informations that cannot be properly allocated in these files should go to a specific file, another different file, in order to store that information that is specific for an assessment or is specific for a country, and so on. So the idea is to collect all these files and to store them in a unique file with a zip process. Okay, we zip these files, and then we rename that extension to the iEPB. This is something that is already a common practice in other softwares. For example, Microsoft, the docx file, really, this is a zip file. If you rename that extension to zip, then you can unzip that file and you will find different XML files that contain, sorry for that, that contain the information. So what we are proposing is a complex file that contains different XMLs with information. The idea is to store as much information as possible in the GBXML format. Everything that can be allocated in this GBXML format, following the standard for that format, should be allocated there. Because doing that is the way in order to make more easy to reuse that information for future assessments that will require this information. So, for example, the idea is to store information regarding location, regarding the envelope, regarding material, constructions, thermal zones, internal heat gains, and HVAC equipment. Our proposal, let's try to store this information in this already existing file with an already existing standard to create it. This is an example of the information that can be stored in the GBXML file for a material. This is a drywall. So as you can see here, we can store everything, all the physical properties that can require. No, not all of these fields are mandatory, but if you have that information, you can store it. So in the GBXML, you will store the information regarding the material. You will store the information regarding the construction, and so on. So, but what happens with information that is not related, or that cannot be properly allocated in the GBXML? So that information should go to the specific file in order to keep it separated from the GBXML. So, for example, information regarding the SRI, most of the information regarding the SRI should go to the specific file, should go to another file. Here we have our proposal structure. This is an example of the specific file in order to complete the information that is allocated in the GBXML. We propose to start with a XML block for each country in the for each country in the union. We propose to store to have a block for Spain, for the Netherlands, for Austria, and so on. Then we propose to have a building data block inside the country block, because most of the time SRI or EPC or life cycle global warming potential is going to store information regarding, for example, the postal address of that building. Okay, that's information that is being common for all the assessments that the EPBD requires. So we are proposing to have this block that it will contain information that is common to all the assessments. Okay, for example, this is an example of this common data block, a construction year, applicable legislation. As you can see here, applicable legislation is going to be something that is dependent of each country. So for that motive, we introduce that information in that in the block for that country. Then, okay. In the country, we will have a block for each of the assessments, SRI, EPC, and inside those blocks, okay, let's go to that one. Okay, so inside each block of EPC, in Spain at least, we have different softwares to issue an EPC. So inside the EPC block, we are going to find different blocks, each of them for a different software. For example, if you have information that is required by Citrix, you will fill this block. But if you are using Therma, that is another software, you will fill the specific block for that software for Spain. Okay, the idea, I remember you, is to introduce in these blocks information that has not been properly allocated in the previous block. Here, you are going to introduce information that was not properly allocated in building data and that was not previously correctly allocated in the green building schema file.
For example, here in the text tool, we have some data that is regarding the way the tool calculates thermal transmittance of walls, roofs, and so on. So it's a characteristic of this tool. So we will include these characteristics inside the text tool, the text block.
Mm-hmm. So, yes, this is the example. Okay, there is somehow a heritage schema. For example, you see, as Marta has mentioned, in our software block, we find construction. Okay, this block is already present, is also present in the green building schema. Okay, we can find a construction block with this ID. But in the green building schema, we cannot store some properties that our software requires. we cannot allocate what construction type it is, or what's the wall composition. Okay, this is very, very specific information that we require in C36. So we complement the information that is present in the green building schema with the information that is that is needed in our software. Doing that, we are making easier to reuse that information for a future software or for a future assessment or for a future calculation. Because everybody, okay, sorry, I have a funny mouse here. Okay, really, I don't know where I was. Okay, so okay, really, it's difficult for a third party to find and to interpret this information, because this information is okay, is specific for C36. But sorry for my ya no sé dónde está. Sorry. Okay. But information that is in the green building schema, that means information related with the dimensions of the wall and information regarding the thermal transmittance of the wall and
Yes,
the orientation. Okay, that is in the green building schema. And as it is an open schema, and everybody that is developing applications related with energy efficiency or related with buildings, okay, it's easier for them to know the green building schema than to know the information that we require in C36. So, okay, this is a very short explanation on how we are proposing this common format for all the, okay, it's not a common format for the EPCs. Really, it's a common format for all the assessments that are related with the EPC. In this schema, we not only include input information that is required for the different assessments, but we also include the output information. And this is very, very important, because in many, many cases, the output of an assessment is the input for the next assessment. For example, the energy consumption of the EPC, it's very, very probable that is the input for the life cycle global warming potential, because it requires the energy consumption in the use phase. So really, we are proposing a common format for all the different EPBD assessments that include input data and output data, all in just one file. Okay, thank you for your attention. And okay, if you have any questions, we will be very happy to answer it.
So this is just a brief overview of the presentation. So a little context on Portugal, some experiences using in the EU using the EPC databases, some expectations from our side and some challenges. So just a few figures to support. I won't go into much detail, but just to say that we have quite a comprehensive building stock in Portugal, 3.5 million buildings, mostly single-family houses. Half of the people live on those single-family houses in terms of households, which are 6 million. And you can see also by construction date that as in other countries, we do have a lot of older buildings before the 90s, which didn't have any requirements. Just a brief overview on the energy performance of residential and non-residential. So you can see kind of a mixed distribution on residential and very much a reference value for the non-residential, as we already have maps implemented in Portugal that align with the C label. That's why you see many of non-residential being A+ to C. This is just a brief overview of what's happened in terms of EPBD transpositions and the evolution of legislation. Perhaps I would just refer to the last column, where we have, I would say, everything more or less settled, also with around 550 EPCs being issued every day for around 200,000 EPCs a year. Just a few figures since 2007. They keep getting they need to be updated, but roughly we're coming closer to the 3 million EPCs, a large number of the building stock already certified, around 40%, with good numbers for public buildings and non-residential, more than 2,000 qualified experts, 5 million recommendations identified. You can see also in terms of investment and savings. But on the right side, perhaps more interesting, it's the database that comes close to 600 million entries. So we do collect up to 300 variables per building. So the structure that we have now, as you can see in these 8 categories, we do have a lot of variables for technical systems, energy balance, envelope, but we are trying now to revise a little of this in order to perhaps go to a buildings portal and structure instead of a EPC structure, because everything was very much developed around EPCs, and we are now collecting much more than just EPCs. This is just a rough idea of what we have been doing with the EPC data since that time in terms of supporting policy making in blue, incentivizing renovation actions in orange, or supporting stakeholders in green. I won't go too much into detail, but this gives you more or less a rough idea of the use of the data coming from the EPC, which is very relevant for many situations, specifically for supporting the policy making and also the renovation actions. Some experiences in the using the EPC database. Actually, Andre have already referenced the ELISE. This is just pointing out to the JRC technical report about the initiative of harmonization data sets on EPCs, some conclusions that the different EPC schemes make it difficult for comparisons. An harmonized EPC scheme would be very beneficial. Also, regional energy agencies can actively support energy efficiency policies with these. There are some like also Andre mentioned, this was based on something already using initiatives in Italy and in Spain, and this methodology can be reused also to go further in terms of this kind of harmonization. So we see a lot of talks about harmonization in terms of data structures, in terms of potentially calculation approaches, and etc. But there is no something very concrete or widely used by member states at the moment, and I think that would be very beneficial. Also, some information from the CAPBD in terms of kind of data is collected already in the EPC databases. As you know, this was not mandatory, but all member states except Germany, at least for a few years, I don't know if they have already set it up, I think they are trying to do it now, have EPC databases, and each one decided what data to collect. Well, as you can see, most of the expected data is already included. So these 30 means countries/regions, because it also has some regions like Brussels, for example, but you can see a lot of data on buildings, on EPCs, IDs, on technical building systems, recommendations, building envelope, etc. And a little less on geospatial data, inspections, real energy consumption, and other way. You can see already beam data that was something that, I don't know, 4 years ago, more or less, was already being included in 2 databases. So a little information about the variables and size of the databases. So there's no approach or harmonized approach here, as you can see. So but on average, each EPC is collecting around 200 variables. The EPC databases are also quite different, also taking into consideration the format of data that they're collecting. Some of them are collecting PDFs and etc. Others just collect the data itself, then generate PDFs when needed. And also interesting to see that each EPC has on average 1.5 megabytes of space, but it can roughly go from 300K to 14 megabytes. We also try to evaluate interoperability. I won't go into much detail, but you can see that a lot of interoperability is already happening in terms of exporting in orange the data, aside from the cadastre and land register, which is actually a lot of data being imported. But there are already very good experiences also linking with financial entities, which I'm pretty sure has increased a lot now with taxonomy and such. And this is, I believe, becoming older information. So in terms of frequency, most of the things were happening at the time on requests. So some situations were really on real time, on daily basis, but mostly interoperability is happening on request by each entity. And the way the data is being shared, mostly over web services, but in some situations, files are being transferred or direct access, very occasional, direct access to the database as well. This is available on the EPBD report that you can see in the link down there. So some expectations from our side. I would say there are two key topics now happening in Portugal: the EPC database restructure and also the EPC calculation methodologies. I'll go very briefly on these two. So this is more or less a simplified version of the EPC database structure that we have here in Portugal. Of course, the EPC, the energy performance certification, has the biggest block with the building, ventilation, glazed, technical systems and other systems being collected. Then we have modules, I would say, for geography, for the dwellings, for the site visits we have, for technicians, for the experts, for the quality assurance, and also other modules like the energy consumption, the measures, the renovation measures, or the administrative module for the EPCs, reissues, changes, updates, and etc. One of the things that we, a few years ago, started pushing was having identifiers. As we in Portugal, we don't have a single building identifier that could be useful. So we tried to have an approach where we could, over a building level or over a building unit, develop or use the identifiers that could be useful specifically to arrange data and to interoperate data. So we have the Inspire ID, and Ray already mentioned that in the beginning. Then we have Statistics Institute, utilities, fiscal, notary, and the whole EPC references that we use. This is just an example how we are linking the data basically through map services and web services that we have with the National Statistics Institute, where we get access to that data. They also provide the linkage with the Inspire ID. So since the Statistics Institute is the national authority for the implementation of the Inspire ID, this is good because it allows us also to integrate this Inspire ID already. And they also provide some census data. So it's interesting for the expert when issuing an EPC already has some information about the census data and also the building structure. So you can see on the lower side, on the right side, the dwellings ID. So we also know that, okay, I'm doing an EPC for a single dwelling, but I can see also the whole structure of the buildings. And this is also interesting if we want to combine data for different dwellings and have the whole structure, the building structure included. That's on databases. Going on to the calculation methodologies, of course, is a very well-known scheme of the standards. So we are very much looking on how to update it and how to use tools in order to go through the whole calculation processes in terms of energy needs, final energy, and primary energy. Also, we had the chance to look a little on the approach that member states has also on the EPBD. This is just a slide from a recent meeting in Athens, 2022. And we can see that most of the member states, in terms of energy performance calculations, were using monthly calculation, but a good number already on hourly, sub-hourly, or multiple approaches, of course, in terms of perhaps different types of buildings and etc. And very little based on annually approach. So what we are looking for? So we still have an older approach, as I had a chance also to discuss with Diana in Brussels recently. So we still have an approach based on the 13790 ISO standard. So a seasonal calculation method, which is not even possible right now to use it, with fixed internal gains, fixed 24-hour user profiles, equal distribution of consumption per 24 hours, and an energy performance of buildings calculated based on the ratio. So we don't have a specific value for each approach, so we do a ratio approach, as also a number of member states also do it. And we are looking forward to now implement the new standards. So we still see some Portuguese words there that were not correctly translated, but going through the new approaches, still deciding to go or monthly or hourly. And we have seen, like Jana mentioned, that if we go for hourly, that perhaps provide us with a other type of information that could perhaps give us more information about the building's performance, but of course it also might make it a little more complex, I would say, for existing buildings perhaps. So we'll have to reflect the typical energy use, also reflect if we stay with ratio or try to implement fixed thresholds for the energy performance of buildings, and also include which we already have, the emissions per building. On the big non-residential, I think we're better. So we are based on the ASHRAE 140 standard with hourly calculation, internal gains calculated, real use profiles by typology, also distribution of hourly consumption depending on profile, and the EPB calculation is also based on the ratio. So I think the adaptation here will be easily to do it for the non-residential. So coming for the last slide. So the current challenges we faced for this specific purpose, I think, are two. For the database, it's to set up this new portal web interface and the buildings database to integrate all EPBD data, and on the calculation methodology, so update the current calculation methodology that we have and be able to store all EPC data into the new portal, like it's more or less mandatory with EPBD. And so it was good for us also to be able to integrate and make use of the deliverables that we have been discussing in this meeting, coming from the EPC cluster projects, and also to facilitate this, overcome these challenges, and also make sure that everything that we do on projects, and you know very much that ADENE has been also involved in some of these projects, like the SR right to market that was just referred in others. We like a lot that they don't get stored in a shelf that nobody uses it. So it's important to make use of these outcomes for the whole EU. And I think that's also a little what Andre is trying to push in many initiatives, that is make correct use of all the deliverables of the projects. And it's one of our expectations also with this meeting. So, and that's all from my side. And of course, I'm also very happy to answer some questions that you may have.